Hi, it's Terry Dennery of the MathWorks. So this video, we're going to start where we left off on the previous one. We did a mass spring damper. And I think I asserted, a fairly bold statement, which said that kind of the basics or the fundamentals of controls are already in this. And so I'm going to be a lot more specific what I mean by that now. And one of my main points is the spring damper is very much like feedback control. And the idea that we can use calculation to kind of figure out, how to move a system, that's very much like feed forward. So anyways, but before we get to that, I'm going to do a couple of things, all right? And I'm going to kind of make the case that this is really an environment description. Maybe I'll even get rid of the M for right now. And I'm going to pop that into my, I'll call this my plant model now. All right, and that this is going to be essentially a description of the environment in which this thing's going to be operating. Right? And there's a couple of reasons I like doing it this way. All right, so it's got this new port in here. I'm going to just call it environment. And we know it to be the gravitational acceleration. Maybe it is, let's just call it environment gravity. Right? And I think that we could multiply it by m and then we could divide it by m. I think it's kind of obvious where we're getting here. Well, to again kind of retain this idea that forces are forces and accelerations are accelerations, I will do something that's beginning to approach being silly. All right, and I am going to multiply it by m. And I'd say there are good reasons for that, which is it works is the first one. And again, going off script, going out of process, sometimes you do make mistakes. So keep it like that. And we'll introduce an add block. So the overall force being felt by that mass will be the force that we will apply. We're going to start calling it the control force pretty soon, but for right now, we're going to just kind of continue to not really change the model. And I believe that if I hit run here, we'll get the same thing. Right? So it's, which we do. All right. So, okay. Right. So I do have this kind of convenient block here, and I'm going to bring it back over here. But this time, what I'm going to do is change the sign back to positive, and I'm going to multiply by m. And so I'm basically going to balance that gravitational force. All right. And so here's the result from the last run. So when we run it this time, I think we'll see zero movement, which we did. All right. And if we measured this force, which is based on the displacement and the velocity, we know that that would be zero as well. All right. And so in a way, that's a feed-forward controller. It's a feed-forward controller that does nothing. That's basically not going to move. But that's the beginning of our feed-forward control. Right. And so now what I'm going to do is I'm going to introduce the idea of a trajectory. And so now what I want us to kind of consider here is the idea that this is like a vertical takeoff, flight vehicle, right? And so the trajectory really does matter, right? And so that's why we have an additional port here, right? And it's kind of the same old, It's like, that plant doesn't care where the force comes from, and we're going to even get rid of this. Well, we're not going to get rid of it. What we're going to do is we're going to put it on the shelf. And so I'll comment that out, right? So spring damper is commented out now. And so over the years, I've done lots and lots of trajectory stuff. And so I'm going to kind of show you these little trajectories I've put together. So this is Terry's electrical and mechanical components. You'll see mechanical components right here. And you will see motion signals. And so we get a smooth step position. I think I'm going to leave it out like over there on the left a little bit. All right, and so let's get a gain block. All right, and so we want to add up both the gravitational force as well as the acceleration force. So again, F is equal to ma, so this gain will be m. And we don't, actually I'm going to show you what this is in a second too. So, but for right now, I'm going to get a selector out. And you might recall from the previous video that PVA, position, velocity, acceleration, A will be the acceleration. Right? And that'll be the third component. And so being at 1.5 seconds, let's do a ramp that will take 3 seconds and we'll go from 0 to 5 meters. So not a big vertical takeoff, but maybe it's like a small little quadcopter. 5 meters is pretty good for a quadcopter. So let's go ahead and see if I did all that right. We'll hit run. And it sure looks like it worked out pretty well. Right? So again, this is the movement, the position of this mass as a function of time. And I said in 3 seconds we go from 0 to 5. It looks like we did it. All right, so I'm pretty happy with that. All right, and here's where things, I think, really kind of become much more like the way controls are done. Right? And so what I'm going to do is take all of that and right mouse click, create a subsystem. And this subsystem will be called the feedforward control. I'll call this my motion command. I might even do this, PVA, position, velocity, acceleration, and maybe I'll call this force underscore FF for feed forward. All right, but hopefully that's clear. That we're taking this trajectory, we're taking the third component off, which is acceleration. And so acceleration times mass, and then we add to it the compensation for gravity. All right, so that's my feed forward control. All right, and we saw we did pretty well. All right, and here's kind of the secret to feed forward control. That you get this, kind of perfection when your information is perfect. All right, and it can be kind of easy to be perfect when you're creating plant models on Simulink and you're creating feed-forward controls in Simulink and you're making all the same assumptions. But in the real world, information is not anywhere near as validated as that. That our confidence is, and I'll say even our accuracy to do this isn't nearly as perfect. All right. So, anyways, I'm going to introduce some imperfection here. 0.99. All right, so that seems pretty close, right? If it's 10 pounds, we're saying, well, in reality, it's 9.9 pounds, right? And so we're going to hit run, and let's see how we do. Oops, forgot to compensate for most of the loads carried by the gravity. So anyways, please excuse me for this, 0.9. And in a way, you're kind of seeing, here's kind of the way I really should have done this too. Just to kind of not have multiple definitions all over the place. So it's, oops, shift, take that out, bring that back like that. right? So now the mass will be adjusted consistently between both the gravitational force and the acceleration force. And hopefully I'll get the error that I was anticipating, which I do. Okay, and so again, it's this idea that our information is really good, but it's off still just a little bit. Okay, and being off just a little bit means that this approach of feed forward, really, you better be careful about it, right? And so, anyways, what's the correction? The correction actually is a spring damper, all right, and they don't call it that, all right. And so we're going to get into this a little bit here, and so we'll bring this back. And so what it's really called is, in this example, will be a PD control, right? And so I'm going to begin by going in here, and I'm going to name that feedback. All right. Now the other thing I'm going to do is I'm going to create another one of these. And actually, it's probably smart for me to put this up here. So let's put this up here too. Paste. Right, and this one will be called command, CMD. And we'll move these down here a little bit. Right, and so anyways, I'm kind of asserting this idea that there's an analogy, right, to it. All right, that a spring damper is like it turns out to be a PD control, right? And right, and the way it kind of works is pretty close to what we have here. And I'll just say these are notational things, but they are important, all right? And so it's no longer, I'm going to go ahead and keep K in there. Normally that'd be called, actually, well, we already got it defined in our data file, so I'm going to continue to keep it. But I'm going to change the order of operations so that essentially that minus sign will show up in a different way, all right? And so let me get this now, all right? And so this difference between where we want to be and where we really are, oops, will be defined this way. So it'll be commanded vertical position, subtracting the measured, and then we'll do the same thing on the damping. So let's bring another one of these down here. And commanded velocity minus the feedback or the measured velocity. Let's make the command be the number 1, so it will show up right here at the top port, right? And anyways, what's our command? Well, that's our command right there, right? And so this is really kind of the basics of control, very clear here, that it's a command signal. It's a thing we call the controller. It's a representation of the environment. It's the plant, and then it's the measurement. Anyways, let's go ahead and kind of try that again now. We'll hit run. We're nailing it again. So, anyways, mass spring dampers are more than just interesting mechanical problems. They really, at least for me, really kind of define the concept of how we apply feedback to get better control. And I use this term a lot. Probably a lot of my controls friends, they don't like it, but I say the feedback controller, it's like a little rubber band. It kind of keeps that thing that you want to happen really kind of glued or connected to what the thing that's operating in the real world is doing, right? And so this idea of stretching and applying more force and all that kind of stuff. Certainly that's what springs do, and that's what PD controls like this do. And as you can see, it works real well. Thank you.